Greetings, space explorers and lovers of the unsolved mysteries of the universe. You are watching our longest and perhaps most intriguing video dedicated to an object that has prompted Harvard professors to talk about extraterrestrial intelligence and astronomers to rethink the fundamentals of comet science. Today we're looking at Comet 3I Atlas, a space traveler from another star system that could be a comet, or it could be something else entirely. We're not just going to tell you the facts. We will delve into scientific debates, analyze anomalies, and consider all the arguments in favor of the most daring theory, that 3I Atlas may be a technological probe. Get ready, we have an hour of real space detective work ahead of us. Let's start with the basics. In 2025, the Atlas system, an early warning system for asteroid collisions operating in Hawaii and Chile, recorded something unusual. The object was moving fast, but more importantly, its trajectory was hyperbolic. Mathematically, this means that it is not bound by gravity to our sun. It is simply flying by and will leave our system forever. This is how the third confirmed interstellar visitor in history was discovered, officially designated 3I/Atlas. As you may have guessed, the two letters I in the name stand for interstellar, and the number 3 is its serial number after the famous 1I Oumuamua, 2017, and 2I Borisov, 2019. And here lies the first intrigue. Oumuamua was cigar-shaped and had no comma, while Borisov was comet-like. Atlas, on the other hand, looked and behaved like something in between, which immediately raised questions. Unlike its predecessors, 3I Atlas was detected before it approached the sun, which gave us unprecedented time for observation. This object flew to us from an unknown point in the Milky Way and travels at a speed of more than 200,000 kilometers per hour. On its way, it carries untouched samples of matter from another stellar cradle, which makes it invaluable to science. But what does this messenger look like? It is an active comet consisting of a solid icy core, Atlas's nucleus, estimated to be less than 1 kilometer in diameter, surrounded by a coma, a cloud of gas and dust that is released when heated by the sun. The comet passed its closest point to the sun, perihelion, and did not come closer to Earth than 270 million kilometers, making it completely safe. Scientists were confident that they would be able to solve the mystery of Atlas using the Hubble and Webb telescopes and even European spacecraft orbiting Mars and Jupiter. But the more data they collected, the more questions arose. The main anomalies that made Atlas headline news around the world can be divided into two types. The first and most serious is abnormal acceleration. Comets, as we know, do not move solely under the influence of gravity. When the ice in the nucleus evaporates, it acts like a tiny rocket engine, gently pushing the comet. This non-gravitational acceleration must always be directed away from the sun. But data on Atlas showed that its movement cannot be explained by standard models. It accelerated as if someone were controlling it, or as if it were being pushed by something other than the usual evaporation of ice. The second aspect that struck astronomers was its anti-tail and chemical composition. At one point, as it passed a perihelion, Atlas displayed a jet of gas and dust pointing directly towards the sun rather than away from it. This phenomenon had been observed before, but here it was particularly pronounced and long-lasting. Scientists cautiously explain this as either very heavy dust particles that the solar wind is unable to move, or an unusual degassing mechanism. In addition, analysis using the James Webb Telescope has shown that Atlas is extremely rich in carbon dioxide and contains concentrations of gaseous nickel and small amounts of water ice that are unusual for comets. All these chemical and dynamic features together created the perfect breeding ground for the most radical theory. It is at this point that Harvard professor and astrophysicist Avi Loeb enters the scene. Avi Loeb is a scientist who believes that we should not rule out the possibility of interstellar objects having a technological origin, and he has already put forward the hypothesis that Oumuamua could be a kind of solar sail. In the case of Atlas, his arguments have become more specific. Loeb argues that the anomalies in the motion of 3I Atlas fit the model if we assume that the object controls its own motion. If it is a technological probe, then the non-gravitational acceleration can be explained either by the directed ejection of a working body or by the pressure of sunlight on a thin, artificially created surface, i.e. a solar sail. Why fly to our solar system at all? From Loeb's point of view, this probe could have been sent for reconnaissance, and its comet-like appearance is a form of camouflage. He points out that if Atlas were artificial, Its shape and structure could be optimally tuned to utilize solar pressure and create controlled maneuvers, unlike a shapeless comet. Loeb and his supporters suggest abandoning Occam's razor, i.e. not reducing everything to the simplest natural explanation, but considering all possibilities including technological traces. In their opinion, we should actively search for such technosignatures in the data. However, this is where a heated scientific debate begins. The vast majority of astronomers consider Loeb's hypothesis to be speculative. They insist that Atlas is a comet and that its abnormal behavior, although unusual, ultimately has a natural explanation. For example, the anti-tail can be explained by large, slow-moving dust particles, and the unusual acceleration by the uneven distribution of active zones on the nucleus, which leads to asymmetrical thrust. They point out that despite all the anomalies, Atlas has a distinct coma and tail, emits gas and dust, which is classic behavior for a comet, not a piece of metal. Furthermore, no radio signals or other direct evidence of intelligent activity have been detected to date, which is required for definitive confirmation of the techno-trail theory. It is accepted in science that extraordinary claims require extraordinary evidence, and so far Atlas has not provided such evidence. But regardless of whether Atlas is a comet or a probe, it has given us an unprecedented array of data. The comet passed very close to Mars, and European Space Agency spacecraft such as Mars Express and ExoMars TGO were able to make direct observations. This data helped to measure the composition of the coma and the rate of water loss. The Hubble and Webb telescopes provided images that helped to estimate the size of the nucleus and study its chemical composition in detail, confirming the presence of unusual substances such as the aforementioned nickel and excess CO2. Unfortunately, observation of Atlas was hampered by the fact that it passed through perihelion, coming very close to the Sun, which made it virtually invisible to ground-based telescopes during the most critical period. Scientists are also working on understanding what will happen to 3I Atlas next. Comets that actively degas near the Sun may not withstand the thermal and gravitational stress and break apart, as often happens. If Atlas broke apart, it would be a strong argument in favor of its natural origin. If it survives its perihelion passage, it will only fuel the debate about its extraordinary durability. The main thing that 3I Atlas has given us is the realization that interstellar objects are not rare, but a new class of objects that we now have a duty to study. Studying their composition, their exotic chemistry, different from that of our solar system, helps us build more accurate models of the formation of planetary systems throughout the galaxy. These celestial bodies serve as messengers, telling us how the same chemical elements can form completely different worlds under different conditions. Atlas prepared us for the future. In the future, when more advanced telescopes, such as the Vera Rubin Observatory, become available, we will be able to find such interstellar objects not once every few years, but perhaps several times a year. This will allow us to develop plans to send special interceptor missions to catch up to these objects and study them up close. It is the ultimate dream of astronomy, to obtain physical samples of matter from another star system. So, regardless of whether 3I Atlas was a comet or a probe, its visit was critically important. It pushed the boundaries of our understanding of comet science and raised the question: how ready are we to discover alien intelligence, and how ready are we to accept that the universe may be much stranger than we thought? So we have examined all aspects of this incredible object. 3I Atlas is not just a comet, it is our interstellar teacher, which has made us look at the stars with a new, deeper, and perhaps more paranoid hope. If you've watched to the end and are ready to continue this cosmic journey with us, don't forget to like this video. Subscribe to our channel and be sure to write in the comments which argument in favor of technology or nature you found most convincing. Your opinion is very important to us. See you soon on our channel, where we will continue to unravel the mysteries of the universe.